Hello, good morning, or good evening, depending on where you are. I am your host and moderator. My name is Sriraj Nair from Tata Elxsi. Thank you for taking the time to join us today as we talk about the topic digital innovations for rail transportation. You will leave with what are some of the rail industry's most pressing issues that digital technologies can address, along with the demonstrations of Tata Elxsi's digital capabilities for addressing passenger convenience, safety and security, and predictive maintenance. So please stay tuned to learn more about it. Today, we have a 60-minute session, 40 minutes of presentation followed by a 20 minutes of Q&A. And to make sure we are helping you as best as we can on this topic, we have a chat box to source your questions. Feel free to drop your questions on this topic or share your struggles and experiences. We will answer your questions by the end of the session. We will collect the most important questions so that we can answer them for you at the end of the presentation. Also, do not worry about making notes immediately since we will be sending this session recording your way in next few days. So without further ado, let me introduce you to the speaker of this session, Mr. Sandeep MV. Mr. Sandeep comes with 2 decades of experience across transportation industry, especially automotive, rail, aerospace industries, and he has managed various roles including project delivery, program management, and strategy development. Welcome, Mr. Sandeep, and stage is all yours.
Thank you, Sriraj, for the introduction. So let us get started. I'm assuming I'm audible enough to everyone. Hello, everyone who has joined this webinar from various geographies. Hope you all are doing well and safe. Thank you for joining this webinar on digital innovations for rail transportation. I will start with a quick overview of Tata Elxsi. We are part of the 110 billion US dollar Tata Group. Tata Elxsi business focus is into product design and engineering, and we work with many of the well-known global brands, right from conceptualizing new products all the way to designing and engineering them to achieve production level maturity. We also have a mature digital practice which offers end to end services covering consulting, architecture, development, and managed services for digital technology enabled solutions. We work with our customers in primarily three verticals: transportation industry, which includes rail, automotive, off highway equipment sector; media and communications, which includes wired and wireless technologies, including 4G and 5G; and healthcare. In the next slide, we will have a quick look at our capabilities in the rail industry to set the background before we get into the details of the topic of this webinar. Within rail industry, we focus on scope areas of rolling stock and systems, smart mobility, wayside and signaling, in product development, signaling application engineering, and system integration. We have been working with rolling stock OEMs as well as system suppliers across the V cycle of the systems engineering, including for systems up to SIL4 maturity. We also bring unique capabilities in industrial design, human factors, and user interface design, in addition to mechanical engineering expertise. For the digital scope, we leverage our rich experience in embedded systems development, our experience in communications domain, and combined with our experience in new age digital technologies like IoT, cloud, AI, ML, big data analytics, and edge computing, we are well positioned to be a valuable innovation partner for solving various challenges faced by rail infrastructure owners, rolling stock OEMs, and train operators. We shall now have a look at the scope of the digital solutions in rail transportation in the next slide. This slide presents the various use cases which are our focus areas for digital solutions in the rail industry. We have been working with customers in developing digital technologies enabled solutions across the various geographies. Due to the time constraint in this webinar, we'll be looking at only some of our solutions and discuss technical aspects of the solutions developed. We have grouped the solutions, excuse me, we have grouped the solutions in some logical groupings as you can see here. Let us look at what we cover for the rail platform. Under this, we cover themes such as accident threat detection, security and surveillance, and passenger assistance. Ensuring a passenger does not cross the yellow line near the platform edge, detection of objects on the track, tracking movement of a person or an object which is about to fall off the platform edge onto the track are some of the use cases. The solution also covers use cases such as detecting unattended baggage, detecting any garbage on the platform, and detecting unruly behavior on the platform. For passenger assistance theme, the solution can detect wheelchair-bound passenger and blind person so that timely assistance can be provided by the crew for boarding and deboarding. Crowd analysis of the platform can be done to come up with the density map on the platform, total count of people, which could be used to assess compliance to social distance norms and detect any unruly behavior. For the train, our solutions are for driver assistance and cabin coach monitoring themes. Our solutions for assisting the driver when it comes to detecting an obstacle on the track for collision avoidance, for identification of wayside traffic signs, and for monitoring the alertness of the driver. As part of cabin coach monitoring, we have solutions for coach seat occupancy detection, which can be combined with additional use cases such as crowd analysis, detection of unattended baggage inside the cabin. For rail tracks, our solutions cover detection of various track elements such as joints, turnouts, sleepers, and identification of any faults with them, such as deformations, abnormal gaps, physical damages, missing or loose parts, and breakages. For the wayside, our solution monitors the wayside systems such as civil structures for defects and damages, monitoring of grade crossing, and other infrastructure elements such as signaling posts. I would like to point out that there are also building blocks of digital solutions, as seen on the left-hand side of the slide, which we also focus on, which are required to develop the final solutions. I shall share more details on them on the next slide. When we analyze the various use cases in the previous slide, we see that there are various common building blocks across all the solutions. For example, object detection and classification is one of the key building blocks which is required for all solutions. For passenger assistance, the solution has to detect a human, a wheelchair, a blind person's walking stick, which requires image analytics using AI/ML. For obstacle detection, the solution has to detect, for example, a rock, a log, or any other physical obstruction using sensor fusion. Similarly, there is a need to detect various rail infrastructure elements such as rail tracks, various parts of the track elements such as joints, turnouts, levers, sleepers, and other parts. Likewise, inside a rail coach, it is about detecting a seat, classifying it as occupied or not, detecting whether the seat is by the aisle or not. Once the proper data set is created, the same AI/ML based approach can be chosen to train model for the various use cases. For the object motion extraction and prediction block, some of the use cases such as obstacle detection for collision avoidance, trajectory prediction of a person to detect falling onto the track requires the estimation of one or more elements such as speed, acceleration, direction, which is the second building block. The third block is for object localization to map the object of interest to its physical environment. Use cases such as detection of a rail infrastructure element for a defect requires the element to be mapped against geographical coordinates so that the inspection team can access the exact rail infrastructure element for maintenance. Additional examples where this building block is required includes estimation of distance of a human from the camera position for creating a density map on rail platform. Fourth block of computer vision based measurements is relevant in use cases such as measurement of distance between two people for crowd density estimation or distance of the baggage from the person for unattended baggage detection. Measurement is typically done using computer vision based algorithms. Fifth block is also very important as to develop digital solutions, especially the ones which are based on image analytics. Quite often, it may not be possible to create a sufficient size of data set to train the model, either due to time and effort required to create all possible scenarios, or some specific situations are hard to recreate to capture specific images. In this case, the approach of synthetic data generation is used where objects of interest are recreated using 3D models to create variations. Additionally, GAN-based dataset generator are useful to create dataset which are sufficient in number of images for all the variations and scenarios to ensure AI models gets trained to deliver the right performance for detection and classification. We also have developed digital simulators as well as physical mockups, which can be used to quickly validate any of the algorithms or use cases. Lastly, when it comes to development of a digital solution, we have solution accelerators and frameworks for cloud, connectivity, data analytics, sensor fusion, video analytics, IoT platform, which can decrease the time and the cost of development to market when developing digital solutions for our customers. These software blocks or reusable components are industry proven and thus deliver performance as required in a real environment. I have a few slides later in this webinar to look at some of these solution accelerators. We have also invested efforts in integrating these building blocks for developing various algorithms under the various themes such as passenger assistance, driver assistance, safety surveillance, and infrastructure and rail track maintenance. While developing these building blocks, we have ensured that they are modular in nature, are easily customizable to be upgraded and ported across platforms. Now we will look at the demo video of the solutions for the various use cases and also share an overview on how it was developed and other technical details. The video which I'm going to show, we are going to showcase the intelligent video analytics solution which we have developed, which covers the use cases pertaining to passenger assistance, accident threat detection on platform, detection of unattended baggage, crowd analysis, and detection of rail track defects. The various solutions which you see has been developed on PC platforms, but the developed models could also be deployed on the cloud architecture in an IoT framework for scaling up. So let us look at the video now. Right. Let us look at the use case for the detection of the unattended baggage. This solution was developed combining the AI approach and the CV approach, computer vision approach. Detection of the baggage and the human owner is done using the AI approach. The human owner is then tracked to check the separation distance from the baggage, and considering the time period of the separation between the two and the distance between them, a decision is taken to classify the baggage as unattended. This can then trigger an alert to the rail platform security team to implement the standard operating procedures to deal with the situation. The unattended baggage detection model was developed using transfer learning approach. We used a pre-trained model of YOLO V4, which was then trained with a prepared custom data set to build the unattended baggage detection model. We shall now go to the second of the use case. Yeah, now let us look at the use case of the wheelchair bound passenger detection. So this again was developed using AI approach. It starts with the detection of the wheelchair bound person using AI approach. The wheelchair is then tracked to check the movement and the location. The existing solution can be extended to classify whether the wheelchair bound passenger is assisted or unassisted. In case if it is an unassisted situation, then that can be relayed onto the crew, whether it is on the rail platform or on board crew, who can provide assistance to the wheelchair bound passenger as required. Similar to the previous use case, here also we did use the transfer learning approach and we used the pre-trained model of YOLO V4. Going to the next use case now. In this particular case, this solution was developed using a blend of AI approach and CV approaches. Detection of the blind passenger is done in two phases. Firstly, the passenger is detected using AI approach, and then multiple CV, that is computer vision approaches, are used to detect the walking stick. After the correct classification happens, the blind person is then tracked to check the movement and the location. Detection of the blind passenger can then be passed on to the crew, whether on the rail platform or on onboard crew, who can provide assistance to the passenger as required. Let us now have a look at the crowd analysis use case. For crowd analysis scope, the solution is developed using a blend of AI and CV approach. Detection of the humans on the rail platform is done using the AI approach. CV approach is used to map the detected humans to the rail platform and also to find the distance between the humans. The total count and the density distribution created can then be passed on to the rail platform controller or operational control center to assess whether any measures need to be initiated if a certain threshold is reached to control overcrowding or to alert the passengers to spread out for maintaining social distance. Going to the next use case of dangerous motion prediction. Here, the use case is about trajectory prediction of passengers and for detecting safety lane violation. For this, we are using the combination of LSTM algorithm, which is a motion prediction and tracking algorithm, and machine vision. Any person approaching the yellow lane at the edge of the platform is tracked, and an alert can be raised based on the classification of this movement as a dangerous behavior. We are also currently working on analyzing the emotional parameters by doing facial scan to predict dangerous behavior. This use case can be useful in scenarios where the train is going to roll past the platform without stopping, where it is advised to be well away from the platform edge. Going to the next use case of rail infrastructure inspection. Here, this use case provides a glimpse of using image analytics for infrastructure monitoring, including rail tracks, signaling equipment, and other mechanical or civil structures around the track. Defects such as cracks, breakages, deformations, missing parts, or loose parts can be covered as part of this use case. Using a large data set of rail tracks with defects. The model can be trained to detect damages and even classify the defect. This slide is a summary of the model development approach which we have used for the development of solutions which we saw in the previous slides. When it comes to such use cases, there are three possible approaches one can choose for the model development. Number one can use a pre-trained model and then additional training can be done using additional data set. The second approach is using the transfer learning approach with partial model customization. And of course, this requires expertise. The third approach is using custom model for specific application. Having a high quality data set, which is sufficient in number and also covers all the possible classes of variation, is key to ensuring a good performance in addition to the algorithm and the approach used. Now we shall look at the next video of the solution which we have developed for the seat occupancy detection. Here in this video, what we are going to show is we will show the solution we have developed to detect the occupancy of the seats inside the cabin and how this can help improve the passenger experience by redistribution of the crowd prior to the arrival of the train on the platform. An evenly spread crowd can make it easier to board the trains, get access to the seats quickly, and reduce the dwell time. We shall now have a look at the video.
All passengers prefer to have a hassle-free journey. A major challenge for unreserved passengers is finding out which cars have the availability of seats. And during peak times, lack of information about which cars have free seats makes boarding of trains very inefficient. The travel experience for all passengers can be improved if the train can inform the availability of seats in each car to the passengers waiting at next station prior to reaching that station. Even better if the exact location of vacant seats can be provided. There are systems such as detection of passenger load weights on incoming trains which can be used to provide an approximate indication on loading levels in the cars. We, at Tata Elxsi, have developed a system, using the feed from CCTV cameras, fitted inside the cars, to capture live images, which is processed to derive the seat occupancy information. This will then be sent to display screens, in the upcoming station. The object detection and person classification is done by a deep learning algorithm, using TensorFlow, that includes data preparation and training. Using the trained model on the live data for classification, then finally collated and distributed by a server and HMI application. The display screen provides the seat occupancy status of each car as red, amber, or green, based on the percentage availability of vacant seats. It can also show which all seats are available in a particular car, and particulars of the seat such as window, aisle, provision to keep luggage or bike. Such innovative systems, designed and developed by Tata Elxsi, helps passengers have a comfortable journey.
Right, so this slide shows a high-level architecture of the solution for this system, which includes the onboard CCTV cameras, the module for the object detection and classification, which is the seat occupancy, as well as the person detection. And then this is connected to a web server from where the information can be relayed onto a platform passenger information system screens. We will look a bit more detail into the architecture in the next slide. So what I wanted to highlight in this case is, though we developed this solution for the seat occupancy, the same system can be further upgraded to include features such as violence detection, crowd density estimation inside a coach, as well as camera tampering detection. In this exercise, we did the validation by creating a mock-up of a cabin with seats inside a room. The solution can also classify the seat as by the aisle or by the window to give additional information which can be used as required. We shall now have a look at some of the additional work samples of digital technologies enabled projects which we have done for our customers in the next slide. I will now walk you through some of the various use cases which leverages the power of digital technologies starting from left to right on the first row and then on the second row. The first project what we did, this was a traffic sign recognition project, which was the application of our image processing technology, which we have developed for various industry use cases. The technology can be used for rail sector as well to detect wayside traffic sign and can also be used for road traffic sign recognition or detection of signs in an industrial plant. This project was done for road transportation use case for a supplier. The technology uses AI ML models, which in this case achieved a high accuracy of 99.5%. The second case study on the top row is about generation of the HD map of the environment around an autonomous vehicle using LiDAR sensors. This was done for an autonomous farm vehicle, but the same technology can be used to create an environment model around the rail tracks for detection of the foliage growth. The data then can be sent to a cloud server, for example, to compare the envelope for safe operations of the trains versus the actual envelope available due to the trees and shrubs to decide when and where to send the maintenance teams for pruning. The third case study on the top, on the extreme right, is the real world application of our IoT platform, which is a solution accelerator. Tether, which is it is called, it is currently deployed as part of a connected vehicle platform, currently handling up to 100,000 vehicles for implementing various use cases such as fleet management, vehicle health monitoring, driver performance, remote diagnostics. The platform can be integrated with third-party enterprise applications through APIs and is currently being upgraded to handle Industry 4.0 use cases. Going on to the second row on the left, the fourth case study uses machine learning models using neural networks for predictive maintenance for a gearbox by analyzing the vibrations data. Using the historical data for abnormal and normal gear operations, the machine learning model is able to predict the potential likelihood of failures of the gear. The technology can be programmed for various types of gears or any other mechanical assembly which generates vibrations in rail operations. We have also done a similar project where we used the sound analytics instead of the vibration analytics. The fifth case study was done for a city where it was to check the crowd index for social distancing in a public place. This is again an image analytics project. And the last case study is about a project where we use the AI-based video analytics software to identify potential defects in mechanical structures using visual imagery. The solution uses video image analytics to detect physical damages and also any surface imperfections which can potentially lead to issues in the future. This was done for a steel manufacturing plant, but the technology can be used in rail as well as part of an onboard inspection of rail tracks or offboard inspection of rolling stock wagons. In the next slide, we will look at some of the solution accelerators what we have in Tata Elxsi. So I referred about these solution accelerators in my earlier slides, which are like building blocks. Here in this slide, I will walk you through some of the solution accelerators which we have developed, which can be part of a digital solution for rail as well. These are developed as part of our technology roadmap to meet the needs of the various industries. All of these are software solutions which can be tweaked to meet specific needs of the rail industry. Starting from the left to right on top is the driver monitoring system. This is a camera-based software solution which focuses specifically on the face to analyze the facial expressions and eye conditions to assess the state of alertness of a driver. It is already in use in production vehicles to give audio alert when driver feels drowsy. The second one is an autonomy sense fuse, which is Tata Elxsi's multi-object, multi-target fusion software framework for perception. It is a software platform built to integrate various sensors such as cameras, LiDARs, and radars, and has many out of the box capabilities such as various sensor fusion algorithms to identify objects, classify objects, predict trajectory of object, which can be used for detection and classification of obstacles on tracks, or creation of a 3D environment data for further assessment. On the extreme right on the top is the cabin monitoring system. It is a camera-based software solution which looks at the interiors of a cabin of a vehicle, and it can identify seating and then assess whether a seat is empty or occupied, whether there is an object present on the seat or not. This technology can be used for assessment of seating occupancy status inside a rail coach, which can then be used for smoothing crowd distribution, as we discussed earlier. On the bottom row on the left is Iris, which is a solution accelerator, which is an AI-based video analytics software solution, which can be used for assessing the video feed of IP and non-IP cameras for industrial use cases, including detection and identification of objects, people, scene, fire, etc. This can be potentially used for various use cases for the scope of inside railway station and for inside rail coach for passenger convenience and security surveillance. It can also be used in manufacturing plants or rail yards to detect if the crew or staff is fully equipped with all the protective gear. It currently is being used in a factory to ensure that the staff don't move into a danger zone of a moving equipment, and that they follow the movement zone permitted and they are donning all the protective equipment. This system then can be connected to an access system so that if a worker is found to be lacking in all this safety gear, then the access is denied to the worker. Can Analytics, it is an AI-based edge computing solution which can be used to analyze the data generated from the various sensors or actuators operating on the CAN protocol. This could be used for detecting any anomalies in the sensors or actuators which generate large amount of data, for example, rolling stock doors, which operate multiple times during one train journey. TEDx is our big data analytics platform, which is used for analysis and generation of actionable insights of vast amount of data, which is generated by devices, sensors, or applications. This is implemented at the cloud or server level. The vast amount of data generated by the onboard systems, whether it is part of a regular rolling stock operation or data generated by yellow vehicles, could also be analyzed to see the trends and predict the future state as part of predictive maintenance. Lastly, Tether. It is our IoT platform, which is already deployed for our various customers as part of an overall IT ecosystem. IoT ecosystem, beg your pardon. I'll talk more about Tether in a separate slide later. Any digital solution for rail, which is cloud-based, could leverage the advantages of Tether for realizing a scalable, open standard, secure IoT system. Before I share an overall digital solution architecture in my next slide, I would like to briefly talk about our IoT platform itself. The IoT platform is a very important block which makes up an IoT ecosystem along with sensors, devices, communication network, infrastructure, and applications. Tether is our own homegrown industrial IoT platform, which is already deployed with multiple customers for cloud-based solutions. In some cases, we have not only designed, developed, and deployed the cloud solution, but we also manage the cloud solution on behalf of our customers. The architecture of the Tether can be seen in the slide. Tether can connect with any devices, whether they are IP-enabled, IoT device, or non-IP ones. The platform supports various connectivity protocols such as MQTT, HTTP, UDP, etc. Tether allows interfacing with other cloud systems and can interface with third-party systems through APIs for various functions, including but not limited to machine learning, data analysis, business intelligence, among others. Tether also supports flexible deployment options such as on-premise deployment, public cloud deployment, hybrid deployment. Some of the key reasons our customers have chosen Tether are: it uses open standards. Number two is the licensing model what we have allows access to the source code of the tether. And third, it's a cloud-based multi-protocol, multi-service, and multi-tenant platform. Now I shall go to the final slide of my presentation, which is the overall digital solution architecture. This slide shows an overall picture of a digital solution architecture for solving the various rail use cases in the rail industry. The architecture is made up of the following blocks. On the very left, there are various sensing elements such as cameras, lidars, radar, and other sensors which are used to sense the various physical parameters such as temperature, pressure, vibration, or any other data which comes from cameras or lidars. Then there is a local processing unit, which is a real time embedded hardware which acts like a gateway and does local processing of the raw data generated by the multiple sensors. The local processing unit can then pass on the metadata information rather than the full raw data, which allows the overall system to be more responsive as huge amount of raw data need not be passed to the cloud server. An example of this could be a hardware inside each car of the passenger train, which does the seat occupancy status analysis locally rather than at a train level or cloud level. The various sensing elements and the local processing unit could be on board the rolling stock or yellow vehicle, or they could also be on the wayside infrastructure, such as rail platforms in maintenance depots. Tata Elxsi has some proven solution accelerators, as we discussed in the previous slide, such as Autonomy and Iris, which are software solutions which can be deployed in various real time hardware or even on the cloud. Depending on the design of the solution for a given use case, the data from the local processing unit or sensors can be sent to the cloud server or some enterprise level server, or could be passed directly to the receiving point, which could be a rolling stock wayside infrastructure element. At the server level, Tata Elxsi has industry proven IoT platform Tether, which we just looked at. Various alerts, information can then be displayed to the maintenance team or crew or operation staff on their smartphones or displayed in the enterprise applications. There are some key considerations which are important to consider for a cloud based solution architecture, which are it should be scalable and secure. Second, the architecture should be built on open standards, which allows more flexibility and avoids any vendor lock in. The one who has the rights to do further development and a transparent licensing model. It can interface with wide variety of sensors and devices and also with enterprise systems. And lastly, it should be customizable. Our solution architecture is designed to be extensible, scalable, open, cloud agnostic, and secure. With a combination of lower latency, higher speed, bandwidth of 5G combined with enhanced AI ML models, IoT implementations connected to thousands of devices and sensors will open up newer cases in rail in future than covered in this webinar. With this, I come to the end of this webinar. Thank you for your time for joining in this webinar, and I hope the session was useful in understanding the various use cases in rail which can be addressed with digital solution. I also hope you now understand our capabilities as an organization to realize digital solution for solving problems in rail transportation for rail industry players. I now hand over to Sriraj for the start of the Q&A session.
Thank you very much, Mr. Sandeep, for your insightful presentation. I hope all of you enjoyed this amazing presentation. We encourage all the participants to ask plenty of questions. So please do type your questions into the chat box that you can find on the screen. Now we have a panel to answer some questions that were already sent to us during the presentation. Now let me introduce the panel members. I would like to welcome Mr. Shankar Kumar Rajan, Global Business Head for Rail Business in Tata Elxsi. I would like to welcome Mr. Sandeep MV. I already did his introduction earlier. So Sandeep is Senior Manager in Rail Practice at Tata Elxsi. Now I would like to welcome Mr. Rajesh R. Rajesh is a very senior system architect in autonomous driving and ADAS practice. He has come with deep experience in architecting and developing safety systems. So now over to the panel members for the first question. Over to you, Sandeep, Shankar, and Mr. Rajesh.
Right. I have few questions which I can see here, so I will start with them. So the first question which I have is how is the performance of your algorithms on embedded platforms? So I guess this question I'd like to give it to Rajesh. Rajesh, would you like to take this?
Yeah, I will try to answer this. And we have developed the systems compatible for multiple platforms, and it can be customized for different platforms. And wherever we need the frame rates starting from 20 to 30 frame rates, we are achieving in various platforms. It is compatible for the NVIDIA, Qualcomm, and uh, like Renesas platforms.
Thank you, Rajesh. Yeah, I have another question which I can see here, which is can the implementation of a solution support hybrid system with a mix of on-premise and cloud? So I will take that question. Yes, very much. The system can be architected with the first level of processing being handled, at the edge device level. The data from the multiple edge devices will then be aggregated and analyzed in a cloud platform. This will ensure real-time or near real-time response at the edge and centralized monitoring from the cloud. So this brings the advantage of both. And besides, having a hybrid model also reduces the running cost in many cases. Right. I have another question here. Can your IoT platform Tether be deployed on GCP or Azure, etc., or only on some selected platform? So I'll pass this question to Sankar if you'd like to take this.
Yeah, Sandip. So Tether is platform agnostic. So we have made sure that it is not tied to any particular service provider's platform. So it can be hosted on any cloud platform.
Thank you, Sankar. Right. We have some more questions coming up. So this one is, yeah, AI ML approach for rail fault detection or for any other physical damage detection requires large data set for training the model. How is that managed? So I'll pass this question to Rajesh.
Yeah, I will answer that. See, in one of the slide, we have explained the synthetic data generation aspects of our solution. And we are using the CAT models and some AI networks for generating the additional data sets. Because we'll be using the different backgrounds, different textures, and it will be near realistic objects created in the through the network, and that can be used for the training the model, even for the validation.
Yeah, thank you, Rajesh. We have another question. Does Tata Elxsi's implementation requires any specific hardware platform? I'll take that up. I think Rajesh has already covered it as part of his response to the previous question regarding the performance. So the answer is no, we do not have any requirement of a specific hardware platform. Most of the leading hardware platforms are supported by Tata Elxsi solutions. And examples may include, but not limited to, NVIDIA, Qualcomm, Renesas, etc. Because Tata Elxsi has a very rich experience in embedded systems engineering, in hardware, software, in porting and optimization, it is quite easy for us to port a solution to a new platform. Right. Uh, yes, we have another question. Will the video analytics results vary with ambient conditions like weather, lighting, etc.? So I will pass this question to Rajesh if you would like to take this up.
Yeah, we have the sensor fusion technology used to handle the multiple conditions, especially the certain sensors will be working fine in certain environments, and the sensor fusion technology will come into picture. It can take the best out of various sensors and it will be able to provide the best solution out of that.
Right. Thank you, Rajesh. We have another question. Do rail platform solutions require specialized camera that are expensive? Rajesh, would you like to give some inputs on what sort of cameras, the minimum specifications which are good enough for having our solutions get implemented?
Yeah, it depends on the application mainly, but if you think of the platform solutions, the normal CCTV camera should do a certain purpose. And basically, for the detection and classification, we would require certain resolution for the objects. That's the only constraint we have. Other than we don't want any special camera for any of the application. But for the something like the track inspection side, I think if you want to look closely at the track and get the damage detected, we might require some high resolution sensors.
Right. Yeah. Okay. Thanks, Rajesh, for that. We have one question. Does the solution require high-end servers for on-premise processing? I will take that question. The answer is not necessarily. On-premise processing can be performed on a normal PC with, for example, i5 16 GB RAM, which can handle, easily 3 to 4 video streams for a typical use case, and it can further be enhanced on a need basis. So it's not necessarily a high-end server for doing on-premise processing. So that's okay. Right. So there is one question we have: suitability of sensors used in automotive applications like ADAS for rail. Isn't the field of view, processing speed, etc., critical for rail application? I'll pass this question to Rajesh if you'd like to take this.
Yes, yeah. Anyway, the sensors used in ADAS applications and the rail application definitely should have some difference, because the field of view should be very narrow. Because when we are talking on the train mounted sensors, it will have some ranges of 600 meters plus. And even for the slowly running trains, especially when the train is approaching the level crossing or the platform, we are looking like ranges of 600 meters. And clearly the width of the coverage is in few meters, and it gives a very narrow field of view sensors. And normally the camera sensors won't cover such a high range. Then we need to get support from the lidar and radar sensors, and the sensor fusion should help us in to handle such situations.
Right. Thanks, Rajesh. That's a good comparison between rail and automotive from a application of the same sensor perspective. Okay. We have another question, which is: are Tata Elxsi's algorithms cloud-based, or are they custom algorithms? So I will take that question. All our algorithms are custom made, and therefore they are highly optimized and cost effective. Besides, it can be further fine-tuned for the given use case because we have all the code. At the same time, it maintains the same level of accuracy when compared to similar algorithms offered by cloud-based services. So definitely all our algorithms are custom made, and that gives a lot of flexibility for us to provide a very best performing solution to our customers. So then we have another question here. What is the maturity of your solutions? Are the solutions available as a cloud service? So I will ask Rajesh if you'd like to take that up.
Yeah. See, the modules, what we are describing here, as most of the things we have deployed in, somehow it's tested in most of the functional modules, whether it is for ADAS applications or some other applications. It has been extensively tested, and it's having fairly good maturity. And if you consider the framework components like Tether and all, it's already deployed in many of the solutions in the field. And yeah, if you see the performance results of this solutions, we can see that it's a fairly good accuracy we are getting, especially for the detections and
Right, Rajesh. Thanks for giving insight on that. We have yeah, another few questions here. Let me have a look at it. Yes, there's one question which has come up is what is the range of sensors for track obstacle detection? Uh, Rajesh, would you like to take that up?
Yeah, I think this we discussed the same point earlier. That is the range of sensors. Now, definitely it depends, maybe depending on the applications. For the high-speed trains, 600 meters plus distance is required. And it depends on the type of sensors. And when you talk about our algorithm, it is capable of handling such situations. Image pre-processing and data pre-processing modules are there in our algorithm, and it is compatible for different types of sensors irrespective of the range. And for the if you consider the image processing and the point cloud processing modules, which is handling the camera and the lidar data, and we have certain requirements for the density of point cloud and image pixels. That's all the restrictions from the modules what we have. And mainly what I would like to say is depends on the sensors and is compatible for different types of sensors.
Right. Thanks, Rajesh. We have another question here, which is for the wheelchair detection use case, the solution what you have. Is the approach based on detecting the wheelchair and then detecting the human, or is it detection of both of them together? And how does the two approaches compare with each other?
Yeah, that's interesting actually. See, if you see, the main intention of this kind of wheelchair detection is to identify the person right from the entrance of the platform. And fairly good view will be available from the platform, and the person with the wheelchair can be detected. Normally, the algorithm will be detecting the person with wheelchair and will be tracking the following people and will really confirm that the person is unattended. Then once the person is detected and the wheelchair is not a necessary thing to detect, we can track the person on the wheelchair even in the crowd, so that we'll be able to track him up even he's inside the coach.
Right. Thanks, Rajesh. Uh, I, I'm looking at if there are any more questions coming up from the audience. Right. So we have another question here. Some endangered animals get hurt by the rails in forest area. The question I think says is that we need a solution for that too. Uh, I think the answer is yes. I think a solution is required, and the solution what we have using sensors, which is cameras and lidar, can also detect whether the obstruction which is in front of it is an animal or not, or is it a rock, so that appropriate response can be decided. So using the image analytics, an animal can be or an object can be identified as an animal, right, as long as it is trained. And depending on the typical animals which are seen across around the rail tracks, depending on the geography, this training can be done. So yes, that point is valid. Any other question? Okay. I don't think so. We have any more questions right now. We can wait to see if any more questions are coming our way. Sriraj, would you like to continue the session from here then? If there are some questions which comes up, we can obviously take that up. We still have another 5 minutes.
Sure, Sandeep. Maybe we will wait for 2 more minutes and we can conclude the session. So request all the participants to share more questions if you do have some queries or questions from your end. Also, you can also share us your struggles and experiences so that we can also come up with solutions for the same. Since we are not seeing not seeing more questions, so I hope we can conclude the session. So thank you again, Mr. Shankar, Mr. Sandeep, and Mr. Rajesh for answering those questions and for the great presentation today. It was a pleasure to have all of you with us. So this concludes the webinar. If you have any questions, queries, you can please write to us on the email address shown here, info@tataelxi.co.in, or you can reach me directly at sriraj.n@tataelxi.co.in. So thank you again for attending this session. We hope you have learned and enjoyed this presentation. Thank you and have a great day for you. Bye-bye.
Thank you all.